Hello, hello, everybody. It's good to see you. Here comes your warm-up. So, you stand in front of 10 tunnels, 9 lead to certain death, 1 leads to $1 billion in gold. Do you take one of them? What if it was 5 and 5? Would you take one of them? Would you go back around and do it again? What if 9 led to $1 billion and 1 led to certain death? And what if 999 led to $1 billion and 1 led to certain death? What would you do? Write down a little bit of a sentence for each of these, and let's go ahead and see what's going on. You might want to pause the video because we're going to hit the ground running in 3, 2, 1. Here we go. Okay, everybody. Can I get you back up here in 5, 4, 3, 2, 1. Gavin B., I'm going to say on number 1, I saw most students give me a thumbs down. Gavin, why do you think that most students gave me a thumbs down on number 1? Yeah, you have a 10% chance of something good happening and a 90% chance of something bad happening, something really bad. So this right here, I think I completely agree with this. I wouldn't touch that one with a 10-foot pole. Now, let's see number 2 again. Show me with your fingers, if 5 led to certain death and 5 led to $1 billion, how many attempts would you go? 0, 1, 2, 3, 4, or 5? What do you guys think? What do you guys think? Okay, talk to me. Let's see here. Lydia, what makes you say 2? On number 2, you're saying, I'll give that 2 rounds. What makes you say that? 2 times, so like once, you're like a 50-50 chance, and the second time maybe a little less, maybe a little more. We'll figure that out. That's part of what we're doing today. Ellie, you showed me 1. Why'd you show me 1? Shh, 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 shh. Mm-hmm. Yeah. Half and half, exactly. I'm with Luke on this one myself. Luke, what did you say? A 0. What makes you say 0? It's a 50-50 chance, guys. I don't know if someone walked up to me and said, hey, want to play a coin toss? Heads, you win, you get $1 billion. And I was like, I like this game. And they're like, tails, you lose, I kill you. I'd be like, whoa. I'm going to pass. I'm going to pass. Because ultimately, that's what this is saying. That's what this is saying. That's what this is saying. And that to me, I don't know. I've lost enough coin tosses in my life that I'm like, nope, not, no thank you. Now, what about the 9? Will you guys show me with your fingers? What do you guys think about the 9? Show me with the 9. What are you going to do here? What are you going to do here? Okay, let's see here. Let's see here. I'm seeing a lot of 1s. Maddie, talk to me about your 1. Sure, you're like, well, 1 in 10, it's kind of like if, again, someone took 9 green balls and a red ball, and they put it in a sack and said, shook it up and said, you get the red ball, you fall into a pit of snakes and spikes. Yeah, there you go. And Maddie, I'm not gonna lie, I think maybe we're thinking along the same lines. In my mind, winning $1 billion would basically be the same as winning 2. Like, I don't know what I'm gonna do with that extra $1 billion myself. Did someone want to go more than once? Show me. Who's saying more than once? Who's saying more than once? Henrik, what made you think that? Shh, shh. I'm pretty sure they figured that out. In fact, they oiled it. Yeah. You know what they did? They oiled it. They oiled it. Mm-hmm. They oiled it. They check you for suction cups. Mm-hmm, mm-hmm, mm-hmm. Preston, go ahead. You brought what? Pigs? Sorry. Oh, you know what it is? I remember how they do this. I remember. You know how, like, when you put coins in a slot, it knows what coin it is? So there's a little pig-shaped hole, so if you put in a pig, it'll fall through and all the pigs die. All the pigs die. All the pigs die. In fact, that's where bacon comes from. Go ahead. Shh. Guys. Can't hear Aubrey. I guess that's true. You'll never know. You know, I like that Aubrey's like, if you shut your eyes, you'll never know if you lost. Okay. I got grim. Okay. How about 999? How many of us would give it at least one go? How many of us would give it at least one go. At least one go. Can I get you in 5, 4, 3, 2, 1? Shh. Did anybody on number 4 say they would not do it? Did anybody say on number 4 they wouldn't do it? Tessa, talk to me. I'm not going to lie. 1 in 1,000 is pretty good odds. But how many people here, like if you had to do this, your heart would be pounding out of your chest at the top of that slide? How many of us know that that would be the case? I'm right there with you. I'm like, even if it was 1 in a million, 1 in a billion, you know what I mean? I'd be like, I'm worried. It's there. There's a chance. Yeah, Bianca. Shh, 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 shh. I, I Bianca, I think that that is a very grown-up way to feel because I know I've got like a personality like that too, so I have to avoid like things like that where it's just like, that was awesome, I won, I'm gonna go again because eventually you're right, it's gonna catch up to you, and especially if you have a hard time like on number 2. What if after the 5th one you were like, was that 3 or was that 5? I lost count. I was getting so excited. I'm doing so good, and hopefully you're like counting right. I agree. With 999, well, guys, today we're actually going to put some numbers to this. We're going to put some numbers like Gavin did when he was saying 10%. We're going to put some numbers to this like 50-50. We're going to talk about what those mean. It's the 141st day of school. Did you guys know that 141 is the sum of the divisors of 1 through 13? Let me show you. Let me show you. Oh, don't worry about that. That's next year. Hooray! See you next year, Spheres. Okay. Let me show you. Yeah, we'll talk. Guys, so here we go. 141, one of the... Oh, I have to do that thing. So I got to close this. Hang on. You know what else I have to do? I'm going to blank this just in case because I don't know what's behind that. I'm going to blank this. There we go. Okay. I'm going to close this. Yay! If there's time at the end of class, maybe we can do an unboxing. Let's see here. No. I know. It's because I don't know what was going to show up on my screen, and it might have been a conversation with teachers or parents. So I'm just going ahead and blanking this out. It's thinking about it. Sure, but that's a... Oh, we're good. Okay, guys. Come on up in 5, 4, 3, 2, 1. Okay, let me do this really quick because that thing decided to crap out on me. There we go. Let me see here. I gotta turn this back on so you can see it home. Nope, not that one. Now you're just looking up my nose. Alrighty. There we go. So I'm gonna write down, I'm not gonna do it 1 through 13 because that would take too long. But let's do 1 through 4. So 1, nope, 2, 3, 4. Go ahead, guys. What are the numbers that go evenly into 1? Go. 1, that's it. How about 2? And 1. How about 3? So not 2, because 2 can't go evenly into 3. How about 4? 2, 4, 1. Okay. Now what this is saying is that if we take the numbers 1 through 13 and do this, and then add these, 1 is just 1, 2 plus 1 is 3, 3 plus 1 is 4, 2 plus 4 plus 1 is 7. If we add all these up, we'll get 141. If you go 1 through 13. You have to go through 1 through 13. Hey, it's International Haiku Day. Yay. Can someone remind me what a haiku is? Haiku are fun. Nora. Yeah, exactly. In fact, I wrote a haiku about it being Haiku Day on your time card, which I know, guys, I didn't send out over the weekend. I'm telling you, please stop that. I'm telling you that as well. But that the 7th grade field trip has pretty much eclipsed my entire life. Like I said, I dreamed about it last night, that it was today instead of next week. And I was like, oh no! And then by the time I got it figured out, they already sent a bus full of kids with nobody else on there. And I was like, oh. But anyway, this is, so I'm going to send out your time cards today at some point. So sorry for the thing. But here's my haiku about Haiku Day. Today is the day we celebrate poetry written as haiku. Yay! No, no, let's beat poetry. I don't know. Do they do haikus? I don't know. Anyway, what is our first essential question? And I would love to get that from Mr. Rhett. What is probability and how do I calculate it? Go ahead and write that down. Okay. By the way, our Jeopardy is famous buildings completed in 80 AD, which is fun to say. This Roman building was in gladiator shows, animal circuses, and other diversions is a must-see if you visit Rome. That is indeed the Colosseum. And by the way, the Pictionary is ibid, which is Latin for the same as before, which means it's the same answer. Today, this week, our Jeopardy and Pictionary will always have the same answer. They're meant to help each other. And so on Pictionary, that is also the Colosseum. Oh, now we know. Okay, guys, can I get you in 5, 4, 3, 2, 1? Got a pencil? So, today we're talking about theoretical probability. Theoretical probability. Shh, 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 shh. Let's try to stay focused, everybody. It's not too difficult of a lesson, but I still want to make sure we're all talking, okay? All right, that we're all getting what we need. Okay, so the probability of an outcome is just the likelihood that it occurs. Let's write that down. The probability of an outcome is the likelihood that it will occur. And usually we'll talk about it as things that are very likely, almost certain, not at all likely, uh, somewhat unlikely, OCCUR. So when I say teach, let's come up with some things, guys. What is the likelihood that you will be here at school tomorrow? Is it, and this is different for everybody, is it certain, almost certain, pretty likely as not, unlikely, very unlikely, or certain not to occur? What do you guys think? Talk it out. Teach, teach. Do you really think it's 100%? There you go. That's, yeah, exactly.
Well, I'm probably not gonna be here, but I'm probably gonna be here for a few.
Okay.
It really depends.
Yes. We'll talk. We'll talk. Okay, guys, can I get you in 5, 4, 3, 2, 1? There was a over here at table B. They were saying some of them were saying that they were 100% certain they were going to be here tomorrow, and I had an issue with that. Can someone tell me what that issue might have been? What do you guys think made me think that was an issue, Nash? Yeah, like what if they got sick? Like what if like in sixth period they started throwing up and then they just threw up throughout the whole night and they were still feeling like crap the next day? They wouldn't come to. I sure hope they wouldn't come to school. So I would say that I like the idea that it's almost certain instead of being totally certain, almost certain. There's very little that I'm 100% certain of. Like I'm 100% certain the sun will rise tomorrow. I'm 100% certain. I'm 100% certain. Yeah. I mean, I might not see it, but it's going to happen. What would cause that to happen? I'm trying to think of the events that would cause that to happen. Well, but it still rises, just it rose without us seeing it. So that's what I mean. Okay, can I get you in 5, 4, 3, 2, 1? What I think is interesting is that you guys feel like compelled to put percentages on this, which I think is actually a perfect I think it's perfect that that's the way you think about it because that's the way that I think about it. So let's talk a little bit about it. So, for example, on the cave question or when you're flipping a coin, you'll hear people say that it's the chances are 50-50. So what the heck does 50 have to do with that? When I say teach, put your pencils down for a second. If I flip a coin, your chance, and let's say we're playing for money, which don't do that, but let's say that you say your chances of winning are 50-50. Those are numbers. What do those numbers mean? Talk to each other and let's see how it goes. Teach, teach. Can we get, there we go, that looks good. Yep, go ahead, guys, heads up for me, heads up for me. I know you're tired. You're going to be all right. Okay, can I get you back up here in 5, 4, 3, 2, 1. Okay. Okay. I heard a lot of people saying 50%. So what's the significance of 50%? Why is it 50%, 50%? Why does that matter, Andre?
It's like two things.
Uh-huh.
So like about like the tunnels.
Yes.
Like one was 50% and the other could be 50%.
That's true. Yeah, you have a 50% chance of there were 5 and 5 taking a tunnel and getting $1 billion, but you also have a 50% chance of certain death. Max.
Because it's out of 100.
It's out of 100%. That's exactly right, because remember, the percentage is a comparison of a part to a whole. So the whole number of outcomes, everything that could possibly happen, guys, it is 100% certain. Something is going to happen.
What?
100% certain. Every second of every day, it is 100% certain that something's going to happen. 100%. So, let's talk about why. Got a pencil? Okay. Probability. Go ahead and write this down. That's not how you spell probability, Mr. Petersen. Let's try that again. Shh. Settle in, guys. Settle in. I'm on it. Probability is equal to the number of what we're going to call favorable outcomes. I'm going to put quotation marks around favorable because that means the outcomes we're trying to measure, it's not necessarily a good thing. Like, what's the probability that you'll lose a toe tomorrow, right? Like, that's not favorable, but it's still something we can measure. The favorable outcomes divided by the total outcomes. The total outcomes. And I can't think of an easier place to start than flipping a coin. So we're going to write down flipping a coin. Flipping a coin. Flipping a coin. So guys, one of the things we talk about with probability is something called sample space. That is all the possible outcomes. If you flip a coin, and we're just going to go ahead and say the coin's not going to do that thing that it does in cartoons where it's like standing straight up. We'll say if it's standing straight up, you flip it again, and you just ignore that, you flip it again. What are the possibilities that you can get if you flip a coin, Matthew? Well, what are the possibilities? Well, hold on. Just for a coin. Like when your friend wants to play flip a coin with you, Matthew, what do they say?
Let's flip a coin.
And then they say you want to call
I usually get heads.
heads or tails. So here's the thing. The sample space for flipping a coin is heads, comma, tails. It looks like this. You make this curly bracket, and you say heads, comma, tails. That is, the outcomes are heads or tails. There's no other outcome we need to concern ourselves with. There we go. Heads or tails. Alex, are we writing this down? We should be writing this down, not talking to Caesar. So flipping a coin, heads or tails. How many different outcomes are there? Everyone, there are? Two. Thank you. There's 2 outcomes. Now let's go ahead and say, let's put in our favorable outcome. So that is, what we're trying to measure. So what did Matthew say he always picks? Heads. So if he picks heads and his friends gets tails, how many different ways can Matthew win? How many different ways? There is only one way for him to win, to get a heads. That's why. And this is where it starts to look kind of weird. The probability of heads, and we just put it in parentheses like that, the probability of heads happening is equal to how many different ways can Matthew get a heads? One. How many different outcomes are there altogether? Two. That's one way to say the probability. 1 out of 2. Sometimes you'll hear people say the probability is 2 to 1. This is what they're saying. This is what they're saying. Now, if you punch that in your calculator, 1 divided by 2, you get 0.5, which is half. Right. And then if we do that as a percentage, remember, you multiply by 100, and that's 50%. Matthew has a 50% probability of getting heads, which is the same as a 0.5 probability, which is the same as having a half. After seeing that once, how many of us feel like we've got that just fine? Let's try another one. Got a pencil?
Absolutely.
Okay. Let's talk about rolling a die. Okay? And we're going to call it a 6-sided die. When I say teach, I want you to go ahead and talk to each other. What are all the possible outcomes? When you roll a 6-sided die, how many different outcomes are they? What are they? Put them in your sample space, and let's see how it goes. Teach!
Okay. 6 outcomes.
What are they? Do we have this written down? Okay, where's the coin stuff? Where's the coin stuff? It is? Oh, but what about the fraction? What about the fraction and the percentages? There's stuff in there we need. By the way, between classes, I got the word back. Between classes. Oh, yeah? I did, but I think I left it at home. Tomorrow. Okay. Can I get you back up here in 5, 4, 3, 2, 1? I heard a lot of people say there's 6 outcomes. That's true. But I'm looking for what are the 6 possible outcomes. Rhett, what are the 6 possible outcomes?
1, 2, 3, 4, 5, and 6.
Exactly. Okay? Perfect. There are 6 possible outcomes. When I was a kid, when I was about your guys' age, I used to play this board game called Zombies. It was like, I need to spell it. It was like this. Had the 3 exclamation marks in it. And in it, if you encountered a zombie, you would roll a die. And how it would work is there was a favorable outcome. It went your way if you got a 5 or a 6. So here's my question, guys. What is the probability of getting a good outcome on zombies? Let's see. So let's write that down. Favorable outcome. What numbers was I hoping to get, everybody? 5 or 6. So now my question is, what's the probability? And do you guys mind if instead of writing probability, can I just write P? So the probability of favorable zombies roll hang on, I gave it a curly bracket on accident, equals how many different ways can a favorable outcome happen? Everyone, there's how many everyone there are? 2. How many total outcomes are there?
6.
So we can reduce that to 1/3. which is 0.3 repeating. If you punch that in your calculator, 1/3. Well, let's find out. 0.3 repeating. Now, if you multiply that by 100 to get the percentage, it's about 33.3%. Let's call it about 33.3%. It's about 33.3%. How many of us feel like we understand this okay? You guys doing okay? Good, 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 good. Let's do another one. Let's do another one. Let's see here. Anybody here play D&D? Little Dungeons and Dragons? Little drunk Dungeons and Dragons? So, Dungeons and Dragons has an 8-sided die. So we're going to say rolling an 8-sided die. And the outcomes are definitely 1 through 8. You can get a 1, 2, 3, 4, 5, 6, 7, 8. Now let's go ahead and say that in D&D you're trying to, I don't know, sweet talk the tavern owner into letting you stay the night for free so that you don't have to pay for your room. And in order to do that, you have to roll your charisma. And then I want to know the probability of getting a 6 or better. So when I say teach, I want you to say, okay, can you write a fraction and a decimal and a percentage to represent the probability of getting a 6 or better so that you and your party can stay at the tavern for free that night? Talk to each other, and here we go. Oh, it's a nice inn you've got here. Teach!
Oh, it's a nice inn you've got here.
You guys are well on your way. You guys have high charisma. I like that. Hi, Jones.
So what does probability mean, really?
It's the likelihood that something's going to happen. It's a way to put numbers to like how likely is this. Like, for example, you think getting a 6 or better on here, do you think you're probably going to get it, or do you think you're probably not going to get it?
Like, probably not gonna get it.
Okay, let's put a number to that. So you're going to actually put a percentage, a number to represent that what you're thinking, that you're probably not going to get it. Hi, Josie. Yes, 6 or better. So you can get a 6, a 7, or an 8. Mm-hmm. So there's 3 ways for it to go well, divided by total number of ways. You doing okay there, Lydia? Right, there's 3 ways you can win, right? There's 3 ways you can win. By rolling a 6 or a 7 or an 8. Yes? Well, let's see here. So remember, probability is the number of favorable outcomes divided by the total number of outcomes. How many favorable outcomes are there? 6 or better. So how many ways can you get a 6 or better? Well, which one?
Oh, 3 times.
There's 3. Then divide that by the total number of outcomes. How many total outcomes are there? Yes. There's your fraction. It might be reducible, decimal, multiplied by 100, percentage. Hi, Jones.
So, how'd you get 3 over 8 in this?
So how many ways can you get a 6 or better on an 8-sided die?
3 maybe?
There's 3, right? You can get a 6 or a 7 or an 8. Exactly. 3 ways to be successful divided by 8 total ways. Precisely, Jones. Very good. Hi, Tessa.
Did I do it right? I know.
You got the right idea. Where'd the 6 come from?
Got a 6 or better.
You need a 6 or better. How many of those are a 6 or better? There's 1.
Wait, what?
So we've got all the things that can happen. How many of these are a 6 or better?
2. Wait, no. 3?
There's 3. So instead of making that a 6 over 8, it should be a 3 over 8. Because I have 1, 2, 3 ways.
Oh,
Yes.
so it counts how many.
Exactly. It's like counting how many ways a thing can happen, okay?
Oh, okay.
That's the trick. That's the trick, Tessa.
Thank you.
You're very welcome. Okay. Can I get you back up here in 5, 4, 3, 2, 1. Bianca, how many ways can I get a 6 or better if these are all the ways the dice can come out? There's 3. I can get a 6 or a 7 or an 8, and then we all get to spend the night at the tavern for free. So there are 3 favorable outcomes. How many total outcomes are there, Bianca? 8. So 3 out of 8. There's your fraction. I don't think it reduces. That's 38. Oh boy, I'm really messing this up. 3 out of 8. 8, there we go. 3/8 as a decimal, it's 0.375. And then this is the way that I think most of us like to think of this. Multiply by 100, and you get about 37.5%. Or just move the decimal twice. That works too. How many of us got 37.5%? Or see how we got 37.5%? Beautiful. Okay, here we go again. You're at an ice cream store.
Yes.
I want you to draw 10 circles.
Okay.
Boo?
10. Do they have to be big?
Big enough that you need to be able to write words in them.
That's big.
It's not that bad. Come on. 10. Yeah, but then they won't be the right colors. I do. You don't. Well, hold on, sweet children, and all will be revealed. Well, some of you. Look, if I just go through everybody and say, like, oh, you're sweet, you're not, we're going to be here all day. I'm recording and I'm going to get in trouble. I'm not interested. Some of you are like, I don't need it. I'm good. Ten, please. I don't know. Let's find out. It's okay. We got it. Okay. Can I get you in 5, 4, 3, 2, 1? Shh. Voices off, please. Okay, guys, here we go. I'm going to draw cards, and you're just going to tell me, hey, guys, I would rather do this the fun way, just because it's more fun. But if you want me to make up the flavors, that's fine. I was thinking you guys would. So here we go. I'm going to draw a card. I'm going to ask you for an ice cream flavor that you've really seen. You don't have to have liked it. You're just going to tell me whether or not you've seen it. So, Jones, what's a flavor of ice cream you've seen before it? Strawberry. This first one's strawberry. Why is it green? I don't know. Strawberry. Strawberry. Okay, let's see here. Josie, what's a flavor of ice cream you've seen? Cookie dough. That one's my favorite. I tell you, my favorite thing to do is right around like the fall season, I'll ask for a pumpkin cookie dough malt. That's where it's at. Nora, what have you seen? Oh, Blue Monster? Did you was that at Howdy's Homemade way back in the day? Oh, Howdy's Homemade was the best, man. That works. Okay. Alex, how about you? What's an ice cream you've seen? Bacon? Now, do you know what Blue Monster is? I feel like that's important. I'm pretty sure, guys, I think that this is, just so you know, cookies and cream, plus I think it might have like huckleberry in there. If it's the one that I knew, because that's what they had at Howdy's before Howdy's shut down for the pandemic, it was like the best ever. So yummy. All right, let's see here. What else do we got? I'm just going to draw some cards. We need a few more. We've made it to table J. Oh, here we go. Aubrey, how about you? Have you seen that? But you've heard of it. Count it. Count it. Sardine. I have one that's you know what? Like Normal makes a corn ice cream that I actually really like. Okay, let's see here. Can I get you in 5, 4, 3, 2, 1? Tessa, how about you? Oh yeah, absolutely. Cake batter ice cream. Make sure we're writing these down, guys. You're gonna need them. Henrik, how about you? Fish food? Oh wait, that's with a PH. It's not actually fish food. Do you remember what's in there? Chocolate, caramel, marshmallow. Sounds good. Hey guys, I don't have time. I still need 3 more. Here we go, guys. Let's see here. Aiden, what about you? Moose tracks. Do you remember what's in moose tracks?
It's like chocolate. I haven't had it.
It's got peanut butter cups in it.
It has peanut butter. Just peanut butter too.
It's got peanut butter and caramel, I think. Okay. All right, let's see here. We got 2 more. Let's see here. Olivia, what about you? Kinder Bueno. Oh, so like Kinder Egg? Is that like, that's just like chocolate, basically. Yeah. That's like a chocolate hazelnut. Chocolate hazelnut. And are we gonna be the first group that ever doesn't come up with the one I'm thinking of? I wonder. I'm curious to see. That's the one I keep thinking about, but if you guys don't want to give it to me, you don't have to. What about you, Maddie? What is the one you come up with? S'more. With the graham cracker. Ooh, the coffee ones. Okay. Now, when I say teach, can I get you in 5, 4, 3, 2, 1? At this store, a double scoop of ice cream costs 50 cents. Here's the thing. 1, they have to be the same flavor, and 2, the flavor is selected at random. So my question is, what is the probability that if you give them 50 cents, you're going to get something that you like? 20%. Teach! So which ones?
I do not want sardine and bacon.
Well, talk about which one you want.
Moose tracks or
Okay.
choose all the ones that you like.
Right, that's the favorable outcomes. And then the total outcomes is how many total things. So what's then how many favorable outcomes are there, Aiden? You know what to do? There you go. That's the way. That's what I want you to do. What's that? So here's what they're saying. 50 cents, you get a cone with 2 scoops. They're going to be the same flavor, and you don't get to pick it. So how many of those look delicious? How many of those sound good to you?
Cake batter sounds good. Wait, what are we doing? 2, 3.
3. So how many favorable outcomes are there? And then how many total outcomes? Oh. Okay. Can I get you back up here in 5, 4, 3, 2, 1? Alex, stop it! Don't do that! It annoys me. It's not a moral call. It bugs me. Stop. So, I'm going to go ahead, guys. Strawberry for me. That's check. Cookie dough, you know it. Blue Monster, best ever. Bacon, I'd try it. Not going to lie, I'm not that adventurous. Cake batter, yep. Fish food sounds great. Moose tracks are great. I'm allergic to hazelnuts. S'mores, delicious. So, I have 8 favorable outcomes. So, the probability of me being happy is the 8 favorable outcomes divided by the 10 total outcomes, which is, by the way, is 4 out of 5. So if we do 8 divided by 10, I get 0.8. And that's 80%. I'm not going to lie, guys. I might do it, and then if they give me sardines, I might just throw it away and then try again. Unless they won't let you. They're like, not till you finished eating it. And then you're like, and they're like, and I'm like, oh yeah, I'll just finish it at home. And then someone locks the door, and they're like, I don't think so. And I'm like, oh boy, I don't think I like it here anymore. Anyway, that's the basic idea behind probability, guys. Will you guys go ahead and put your stuff? Well, there it is. Have a great day, everyone. We'll see you guys next time. Well, I'm glad. It's a good thing you didn't get it filled out.